Okay, great. So it's such a pleasure to be here with everyone today. Uh, I have kind of an academic origin, and I would like to share a bit of that with you and show you how that led to sort of the emergence of the XX network. And, there's a lot of other uh, things that I've been working on that are related, and I'd like to share some of that with you as well. So let's just see if I can um, share my screen with you. Yeah, so there's my website, chaum.com. And, what I'd like to, there's a bunch of different projects here, and I'd like to go through them a bit with you, a few of them, to give you a sense of what I've been doing over these years and sort of the where XX Network came from. So I was a graduate student at Berkeley, UC Berkeley. Perhaps you've heard of it, and I think it's probably one of the best, maybe the best public university in the world. It's not private; it's public, and they gave me like a Regents 4-year fellowship, so that was kind of nice. And I was a graduate student in computer science, and some of my office mates and colleagues were people that you've heard of, like Eric Schmidt from Google was my office mate, and Bill Joy was there around the corner, and the Berkeley software distribution was something that my professor made happen, and I was involved in to a certain extent, as were they. Um, so back in those days, this was in the late 1970s. You can imagine that. Um, we didn't really have the web or any of that. And I had this vision for how the future would unfold. And I realized that everybody would be using computers for everything, and that they'd be carrying around little computers in their pockets, and I realized that there were fundamentally two different ways that we could move into that world. One way was by copying the current ideas about how information is stored and maintained, and how people have to identify themselves constantly to protect society, and that everything should be somehow traceable by government, uh, and so forth. And so individuals as data subjects. And I had this epiphany, this idea, it just occurred to me, wow, maybe there's a different way to do it. And that way would be, I like to call it completely inside out. So, in other words, instead of companies and government being able to see everything about you and keep the data about you, and you always identifying yourself to them, you could hold all of this information yourself, prevent them from linking together what you're doing and seeing you online, and which we'll come back to. And then when there is a legitimate query or question from society, government, organization, company, what have you, to you that you wish to answer, then you should be able to prove in zero knowledge that your answer is correct without revealing more than that. And this is, what I called a new paradigm for individuals in the information age. And I think many of you are university students, and I want to tell you that while I was a graduate student, it sounded like a very big idea, but I put it forward, and it eventually reached mass awareness. And let me just show you back to the sharing of the screen that here in this Scientific American article, Achieving Electronic Privacy, uh, this article explained how to do it. And Scientific American is kind of a big deal. In those days, it was the articles were about 3,500 words, and they were quite uh, important. And so, um, let so let me encourage you to try to live up to your if you have a vision or dreams, go for it. Back in the late 70s, early 80s, it was a much more optimistic time. But I don't think that you should just be uh, afraid to act like it's an optimistic world, because we are at a very um, flexible kind of inflection point in civilization, the history of civilization. We could go a lot of different directions from here, and no one really knows exactly which one. And if we don't do something, we'll get sort of the default direction, and that does not look too good. So um, let me talk about mixing briefly, and I'm going to show you video. So brief video. So one of the things, so I was a graduate student at Berkeley, and I was, reading a lot of stuff and trying to think deeply about this new approach that I had and what it could mean. And I found this publication from the Rand Corporation by a guy named Paul Barrett and Barron, and he basically said that traffic analysis, which is what they used to call metadata snooping, was by far and away the most effective way to spy on people. And that instead of breaking codes, which is a lot of work, what's often done, and it was easier, and you get more data, and it's easier to analyze, and it's better quality data, is you study who talks to whom and when. People don't lie about that, and the timing of those messages is important. In fact, I went over to the Doe Library at Berkeley, and they had the congressional record, the books, on the shelves there, and you could see that the U.S. Congress had asked the CIA to explain one of their covert operations, and they chose the coup in Chile, and so there was a congressional testimony by the CIA explaining how they did this, and how they did it was traffic analysis. They basically planted some software in the phone central exchange computer of the presidential complex in Chile, and it would call back to Washington, D.C. every night and tell them who talked to whom and when, and how long the call, not anything about what was said. And it was that data which they analyzed and were able to then find out who and how to take over the country kind of surgically, which they did. And there was a very quick coup and very effective. And Allende was deposed. And so that goes to show you how powerful traffic analysis is. And when you want to do mass surveillance, it's even more powerful because it distills the amount of data that you need, and people don't lie about the data, can't mislead you with what they say, and so forth. And so I had this vision for turning the informational life of people inside out, as I mentioned. And so a key part of it was solving the traffic analysis problem. Because if someone could see everywhere you go and when, then they could tie together all this stuff and spy on you. And so that had to be solved. And so I came up with a solution to it. It's one of the three technologies, or what, two and a half technologies, three that I developed to show that you could turn in the informational, do this new paradigm, and they're reported in the Scientific American article. So how do you solve the traffic analysis problem? Well, mixing. And mixing is a very simple thing, but it's a very powerful thing. And it just says that when you send a message to someone, it doesn't go straight from your IP address to their IP address. Rather, you send it to a single IP address that everyone sends all their messages to. Then that node, maybe an XX network node, takes those messages and reorders them, changes the encryption, and sends them to the next node. And that node does a very similar thing. It takes all those messages, reorders them randomly, and changes the encryption, outputs them to the next node. And so in XX network, we use 5 nodes, and it's extremely optimized. And that's the thing about mixing. You know, mixing is not a one size fits all, just like computing isn't. Maybe you've learned that. That's what I learned in computer science school. You know, there's no single computer architecture that's best for everything. That's why we need AI coprocessors and arithmetic units, you know, whatever, floating point, whatever, all kinds of different computers for different purposes. And it's the same thing with mixing. So XX network is optimized for transactions, which is a very kind of a lowest common denominator for a lot of applications. You can make mixing for a lot of other things, and I'll give you a couple of examples, but they're more specialized, and other people have done that. Or you could do a poor job of mixing with 3 hops, which is kind of an embarrassment, and it's a kind of a egregious, I think, scam. And then you're basically allowing people with a lot of resources to trace. You need more than 3 hops. And so in XX network, we're running currently 5 hops. Every half second, we send a batch through, and it travels around the world through 5 nodes. In, you know, you can look at the dashboard in you know, very, very quickly, in a second or so, a couple seconds. So can we run that video? Can someone?
Suppose Alice wants to send a message to Bob, but she doesn't want anyone to know that the two of them are communicating. Message content can easily be protected by so-called end-to-end encryption, but this does not protect the information about who's talking to whom and when, the metadata, which is increasingly recognized as far more revealing and more challenging to protect. Each member of a team of nodes, in order to protect the metadata, successively shuffles the batch of encrypted messages using its container of secretly arranged tubes and sending the messages without delay through to the next team member. Even just a single node can keep senders from being linked to recipients. Alice also gets a receipt informing her confidentially that her message was provided to Bob. Team members then destroy their secret pattern of tubes, making way for a new team ready for a new batch. Earlier, each node is chosen independently as a kind of random secret key, which input tube to connect to which output tube. Elixir's breakthrough over the type of messaging I open sourced in the 80s is a way that enables almost all the work to be done well in advance, yielding the only known way to provide real-time metadata protection smartphone to smartphone. Elixir, thus, is able to uniquely provide a new, ultimate metadata level protection of confidentiality in all your online communications and payments. For the first time, giving you a protected sphere, protecting your digital world today and your digital future.
Great. So you see, one of the key things in the mixing that we have been running at XX Network is this pre-computation. And that's a real breakthrough, because that's what allows a node, when it receives, say, 1,000 messages in a batch, to only have to do almost no computation to change the encryption. It's just a single multiply. And so the node can very quickly process the message and send it on. So this requires a special blockchain that we've developed at XX Network that lets the team of nodes be chosen randomly by the consensus, but then do the pre-computation, and with the staking, they assert that they're ready to do a round, and they're assigned a round, and then they do it, and if they succeed, then they benefit with incentives. So it's a really nice way to implement something that's very much needed, which is mixing for transactions. Now, there's some new kinds of mixing that have come up, and it turns out, if you look, WorldCoin has a big privacy problem, and that has to do with the scanning of biometric information and how that could be leaked. And I have found a solution to that, which is called Zanzibar, and recently they are backing us to build a prototype of it. Well, that's all based on a new kind of mixing, a special kind of mixing, which we're building into XX Network. And there's a lot of other kinds of mixing for privacy and payments that we're also building in. And so the CMix Plus will be something that a lot of privacy protecting systems around the world will have to be using for all their transactions, and that will really be great for the network traffic, because the more traffic in privacy, the better. Let me tell you real quickly about a couple of crazy things that happened to me personally. I broke the code that was used by Swift in these little blue boxes to protect all of the Swift transactions that came in from the Swift headquarters to the banks, and the authentication and the privacy. And I broke it. We say up one side and down the other, and I used differential cryptanalysis before it was public. And the reason I mention this to you, and you can read about it, but that it's kind of a big deal. A government like that was used to spying on all the Swift transactions, it's kind of hard for them to give up on having access to that information. I'd like to share with you something else that I did, and I urge you to go to my website and look at the multi-party computation work. And you'll see that recently I got all these awards for that, best paper in the last 30 years of theoretical computer science and so on, because it's a very fundamental result. And if you have a theoretical inclination, I would urge you to try to follow it, because there is nothing more thrilling in a professional sense than to make a real breakthrough on a theoretical front. This was, just a standout event in my professional life. And I guess I should also point out a couple of things real quick. That is that I would like to tell you that I also, when I was at Berkeley, in this vein, I also invented blockchain. And I don't want to sound like Al Gore, but if you go here and you look at the publications and you go to down to computer systems established, you'll see here that's my dissertation at Berkeley, which shows how to build a blockchain. But there's also an article here on the origins and variations of blockchain technologies. That is a report that shows that that this blockchain that I wrote the pseudocode for in 82 had all the elements of modern blockchains except for the proof of work, which is okay. So I wanted to point that out. And also this IACR, that's the International Association for Cryptologic Research, and I founded that when I was at Berkeley, because at that time, you can read about it on the ICR panel there on the website, because the head of the National Security Agency of the United States said that you couldn't have conferences on cryptography anymore. So just because of national security. So just as I was realizing how fundamentally important privacy is towards, letting the good way to move into the information age, this guy was saying you can't do any public research on cryptography. So risking spending the rest of my life in jail, I organized a conference on cryptography, which he said, he would imprison people for and throw the whole book at, as we say. So I know it's a different time now for you people at the university and even in business, but I think it's important that we be true to our ideals and let's go for it. If you're interested in helping with some of this stuff, I hope you'll support XX Network. And if you're interested in some of these things on my website, please reach out to me. I'm always happy to work with students. And so thanks very much for the opportunity to speak to you today. I hope you have a great rest of your conference.